Hey everybody, this is your video for 7.3 Math Excel where we're talking about e to the x. And in particular on this one there's a lot of graphing questions like the last lesson. So in a few ways it's going to be similar. For example, in the first one it says use transformations of e to the x to the graph and then give the equation of asymptote and domain and range. So all that is very similar to what we just did before. Now, first of all, before that question, just as notes, I wanted to compare 2 to the x to e to the x because e is about 2.718 as we've discussed before. Remember, it's an irrational number like pi, and it has a decimal that does not repeat or end. It keeps on going, so that's just rounded. Just like we round pi to be 3.14 sometimes, and sometimes 3.14159. So what I did for my comparison, because you just think of e as 2.7 basically, you put the 2 to the x in the calculator with your table, and I just cared about the whole numbers. So that's the one we used to do a lot with 2 to the x. And then when you put e to the x in the calculator, this is what you get. And so you can see at 1, it's just 2 compared to 2.7 approximately, then 4 compared to 7.4, 8 compared to 20. Now that's where it's like really getting different. And then 16 compared to 55. So that's where you can actually see that e to the x is steeper, but both are exponential. So they both are upright like that, and they both go through 0, 1. So the same rules hold as far as like whatever number is in front should be your y-intercept. Okay, so for this one we want 12 e to the x, and so we choose, like from that pop-up menu, vertical stretch of 12, base e. So that would be your graph. Then choose line, dashed, and set y equals 0 for your x-axis. Then press save and check. So all this is like very, very similar to what you did last lesson. Now the equation for the horizontal asymptote in this case is y equals 0. Usually you're going to need to type y equals, so you type y equals 0. But sometimes the y equal is there, and so then you just type 0 if they already have y equal. Then they're going to ask about the domain, which is all real numbers, so you do negative infinity, infinity, and then for your range it's 0, infinity. So on most of these, just like you saw in the previous lesson, your range would be this. Unless the graph is translated down or up, it would be 0, infinity. So if the graph were translated down 5, then you'd have negative 5, infinity. If it were translated up 3, then it'd be 3, infinity. So you just use whatever your horizontal asymptote is. So like in the examples I just gave, your horizontal asymptote would be y equal negative 5 for one of them, and then that's when it went down 5. And when you translate up 3, then it'd be y equal 3. So all these numbers relate to each other for your horizontal asymptote and for your range. So hopefully that's a good review for that. The next part is g of x equal e to the x plus 4. And now it wants you to do a vertical shift up 1. Oh, this is up 4. Vertical shift up 4 from there. So what you want to do on your pop-up box is leave vertical stretch as 1, because that would be like the understood number in front, like that. So that's your vertical stretch. So leave that 1, because if it were 0, then you wouldn't even have a function. So by default, that's 1. Same thing for the horizontal stretch and shrink. So like I'm going to just put the 1 here. That would be the horizontal stretch or shrink. And again, you can't make that 0 because then your exponent would just be 1. So that's why those defaults are 1. And that's true on the other lesson too. I just wanted to bring it up here. Now your vertical shift usually is 0, but in this case you want 4. So that would be like, think of it as plus 0 like that. And then your horizontal shift is usually 0, so that'd be like minus 0 or plus 0, whatever. So that's why that's usually 0. So again, I hope that really ties in everything, what we've been doing. Obviously on this one, don't check reflector X or Y axis because we don't have a negative sign there or up there. So the base is E. Alright, that's the most important part. Now on number 3, you do another graph and it's e to the x minus 5, so that'd be translate right 5, and then just do the same stuff. On this one, it says analyze e to the x on the given interval, and since it increases from left to right throughout, you want to use your endpoints. So this one that I did was e to the x on the closed interval, which means it includes the number -2 and 3. So basically you just do f of -2 and f of 3. So I would just, well, there's two ways to do it. It doesn't matter what you do. On your calculate screen, you can actually just say e to the -2 and then e to the third. So you can do it that way. Like this, showing you where the E button is. If you go to the calculate screen, there's the E button that we've been talking about. And so you can say E -2 and then do control enter. So that gives you your answer right there. And you could do the same thing for 3. The other way I was going to say is if you have more than one, you might want to do it this way. In one of your documents with a graph, if you just keep it as e to the x and look in your table, then you can just find where -2 is and there's your answer, and then find where 3 is for x and then there's your answer. So to me, the trickiest part for students on this would be about rounding. They say round to the 1,000th, and so just as a reminder about that, that means 3 decimal places. So think about like just 0.123. The 1 would be in the 10th spot. It ends with a th. So think of like a regular 10 would be here, but the 10th is the first decimal place. So that's why I put a 1 there. And the 100th, again with a th at the end, is 2 decimal places. That's the one like rounding to the penny. Okay? And then rounding to the 1,000th would have 3 decimal places. So always look like on this one, I'd have to look at my 4th decimal place, decide how to round, whether I round this up or down. In this case, I had to round down to 5. And on this one, I look at the second 5. That makes me round up this to 6. So just make sure you know how to do that. It's basics, but it's been a while. Okay, the next one, write the domain and range using interval notation, and you have e to the x minus 2.8 in parentheses. So your normal domain is -infinity to infinity, so if you move it left or right, that doesn't change it. And your range would also still be 0 to infinity. Your asymptote would still be y equals 0. Now to get the y-intercept, it's usually 0, comma a number, because it's on this axis right here. This is the y-axis. And so you might have a y-int there that's positive, or you could have a y-int there that's negative. So you'd either have a positive or a negative. So what you want to do in this case is just substitute x equals 0 into your equation. So you say e to the 0 minus 2.8, which is just negative 2.8. And that's how they wanted it in mine, because they didn't say to round. They wanted it an exact answer for mine. But if you needed a decimal for it, this is one where you probably could not do in this part of the calculator, but you could in this part, where you just say e negative 2.8, control enter, and there it is. Okay, so that's how you do that. Now number 6, on this one we have the same numbers, the same type problem, except for different numbers and characteristics. So this one you're going right 4 and down 1, so it's the same process. Then for this one, you're investing $700 in an account that pays 6% interest annually, so that means you're only compounding once. You're only using 1 for your variable, but it says you're compounding it continuously. When it's continuous compound, that's when you're going to use e. So normally we think of that as p e to the rx, or like p e to the rt. In this case, they want you to make the equation, so you just put 700 from the problem, keep the e the same, change your 6% to 0.06, and keep it as your variable. And so that's all they want for that one. Then right after that, they just want the domain and range in inequalities instead of your using parentheses, your intervals. So since time can't be negative, because we're not talking about a few seconds before something happens, you're going to have x greater than or equal to 0 for your time. And then your money can't get smaller than what you invested, because we're going to act like the stock market doesn't crash and you don't have less money than you started with. So this would be y greater than or equal to 700 for your money. The last part of this says how much is it in 15 years. And so all you do is you put your 15 for your exponent. So 700 e to the 0.06 times 15. And that would give you about $1,722. So again, thinking of earning about $1,000 after 15 years. So that's good. The very last one is just real simple. It's a multiple choice graph. Just put it in your calculator. Mine had a vertical stretch of 5 and went left 4. Okay, hope that helps.